All right, today we're going to talk about graphing quadratic functions and looking specifically at some of the details of a quadratic function. And let's say that we were asked to graph this quadratic and find the vertex, the maximum or minimum, the axis of symmetry, and the x and y intercepts. That's a whole bunch of information, but it's all right here. We just need to know how to find it and find out what it is. So let's put this function right here into Desmos first. Y equals 3x squared plus 6x minus 4. Y equals 3x, use the caret symbol, squared, plus 6x minus 4. And sometimes I like to, if your picture does not look like mine, remember that you can click this settings button and you can change your settings. On this problem, probably -4 to +4 will give you a nice window like that so we can see what's going on. All right, so first, let's look at the vertex, and that is this thing right here. If you just click, Desmos makes this so easy. If you just click on this low point, this thing right here is called the vertex. Let's label that on our graph. This point right here is called the vertex of the parabola, of the quadratic. And it has coordinates, Desmos told us, of -1, -7. Now, knowing the vertex, here's the nice thing. Knowing the vertex is -1, -7 also gives me two other pieces of information. On this parabola, because it is facing up, okay, this parabola is what we call concave up. It opens up. It has this value down here is what we call a minimum. Remember we were supposed to find the maximum or minimum? This low point down here, this low point, which is also the vertex, is also the minimum. So we could state the minimum with the same point, or sometimes they say, what is the minimum value? The minimum value is always going to be the y value. The minimum value is just -7. It's the low point of the graph. All right? There's another piece of information that we get from the axis, from the vertex, and it is the axis of symmetry. The axis of symmetry is just a vertical line that cuts this parabola into two equal parts. Parabolas or quadratic functions are symmetrical. That means I could fold them on this axis of symmetry and they would look exactly the same. They would fold right on top of each other. So this axis of symmetry has an equation. Back when we did vertical lines, when we did linear equations and vertical lines, we found out that the axis of a vertical line always has an x coordinate. So it's always x equals this x coordinate of the vertex. Whatever that x coordinate of the vertex is, that's the axis of symmetry. All right? Now, the rest of this is stuff that we've already done. All the intercepts. All right? So we've done this before. If we go back to Desmos, erase my extra mark there. Here is an x-intercept. Here is an x-intercept. and this down here is the y-intercept. All right, Desmos tells us all of that. So let's label those on our graph now. Label our intercepts. So this right here is an x-intercept. Okay? This right here is an x-intercept, and we got those values from Desmos just now. The x-intercepts happen at 0.528 and negative 2.528. They happen here and here. Those are the x-intercepts. And the y-intercept happens right here. The y-intercept is at negative 4. All right? So that we have thoroughly analyzed this quadratic function. We have found the vertex. The vertex is down here, which also tells me the minimum, which also tells me the axis of symmetry. Remember, the axis of symmetry is just a vertical line through the x-coordinate of the vertex. All right? Now, I have another one that I would like for you to try. If you're watching this at home, I would like for you to try this one on your own. And I will pause the video, or you can do that so you can try it. All right, you've probably had a chance to start working on this. Let's put this new function into Desmos. Y equals negative 2x squared minus 8x minus 2. And we notice that this one is upside down. The only thing that changes is instead of having a minimum, we're going to have a maximum at the vertex. Everything else we do the same. All right, so we click on this right here. There's my vertex. My vertex is negative 2, 6. All right, so my vertex is right here at negative 2, 6. You can abbreviate it with VTX if you want. Negative 2, 6. That means I also know the maximum. The maximum happens there at negative 2, 6. Or the maximum value, we would say, happens at positive 6. All right? We also know the axis of symmetry. The axis of symmetry will be x equals negative 2, the x-coordinate of our vertex, or our maximum. And then we can go to Desmos and find our x and y intercepts. Our x-intercepts happen here and here, and our y-intercept happens down there. We can see that one's negative 2. And our x-intercept, we have to click on those dots on Desmos. So negative 3.73 and negative 0.268. Negative 3.73, that's this one here. And negative 0.268. Now, the last thing I want to talk about that we haven't talked about yet today is domain and range. The domain of this function is the x values where it exists. Well, this one exists everywhere. It exists from negative infinity to positive infinity. We call that an interval. Every single x value it exists at. The range, these are y values. Well, this thing does not exist at every y value. If we look at this graph here, if we start way down, it does go down to negative infinity, but it stops up here at this y value of 6. It doesn't exist above 6. So the range is going to be negative infinity to 6. So the range has a stopping point on this one. The domain, it exists everywhere. How about on the first one that we did? The range for this one started down here at -7. And it goes up to positive infinity. All right, and the domain is the same thing on this one. The domain of every quadratic function is -infinity to infinity. All right, so the domain for every quadratic is -infinity to infinity. And we will stop there for today.